Good afternoon and welcome Vegas. Welcome to Analytics at Scale. Are you ready? Or otherwise known as welcome to Twins Live on Stage. We honestly didn't color coordinate this, if you were wondering that. Before we get started, a little household remark. This session will be recorded and the slides will be available afterwards. So if you want to take notes, please feel free to do so, but the slides will be to your disposal at the end of this session on the website. We are Erwin and Eric from Tableau's London office, and we'll introduce ourselves a little bit later, but first we thought we'll start by talking about what this session is about.
During this session, what it is that we'll be talking about is how to create a culture of advanced analytics. And what we're going to go through in this is to try to understand first what the current setup is in most of the market that we see. And I just want to pose a question here. How many of you are currently using dashboards that use a connection to an external environment like R or Python?
Just a show of hands.
Just a show of hands here. Yeah, I see a few hands coming up. But I'd say that this is pretty indicative of what we also see, both within the broader market, but also within Tableau's own customer base, that it's not always the most used of setups. So what we're actually going to go through today is first to introduce what we really mean by a culture of advanced analytics, and to sort of give you an overview of what we perceive the gap to be between both different types of users and their skill sets, and to give you a framework for how to potentially improve the collaboration between more data-driven, statistically minded types of users, data scientists, and those who are more embedded within the day-to-day running of their own business functions or business users. We'll talk through how to implement this framework within your own organization, and then, of course, run off to summarize a way for you to actually go ahead and start doing this. We want you to be leaving this session feeling empowered with the knowledge of how you can actually start implementing these lessons in your own organization.
So let's get started, and let's get started by introducing ourselves. My name is Erwin van Laar. Yes, I am Dutch. No, I don't have weed on me. My background is actually not in IT. It's in public health. I did public health, healthcare management and innovation, worked in healthcare for quite a few years, but it wasn't until I actually became a customer of Tableau and started to really unleash my business that eventually led me to actually going to Tableau, where my current function description is literally helping people seeing and understanding their data, which is why I'm here today. Now, I moved to London for that job, and as you can see, some of my hobbies, and I'm sure you probably won't notice, but I'm quite a foodie. And London obviously has some of the best theater in the world, which makes it a great place to be.
My name is Eric Polano. I have a slightly different background. I did my grad studies in applied econometrics or applied economic analysis. I spent a bit of time in grad school trying to figure out what I was going to do. Ended up escaping to tech, like quite a number of us, and found myself at Tableau more asking questions surrounding how we can actually implement more statistically minded techniques in the analysis of data. Now, I'm maybe not as outgoing as Erwin is. I can sometimes be at home taking care of the cats, maybe more often than going out to see a nice play, but I have joined Erwin once or twice for some of those fantastic dinners he knows the best spots of in London.
And we'll leave it up to you to insert your own Bad Cats, the musical joke there. So, as you can see, we sort of represent the two groups of users that we're talking about today. Because on the one hand, we have business users who are domain experts about their business. They are highly focused and concerned with their output, and they want to make the best decisions as they can, making their businesses as efficient and successful as possible. So that is why advanced analytics is useful to them. It allows them to make even better decisions, even faster, with more informed analysis.
Representing then the different type of user that is more and more prevalent in organizations as a data scientist, I'm of course more interested not only in seeing if two types of data processes actually seem to have some high form of correlation, but what can we actually meaningfully say about these types of processes that happen. So in that process, I'm more concerned about the validity of these claims that we would be making. From that point of view, we represent two very different scopes of trying to get to similar types of outputs whilst looking at the same types of problems.
So as a business user, and if you are in this room currently as a business user, we would like to implore you to look at this session and just realizing what is capable for you, what is possible, what you can actually achieve by implementing an advanced language into Tableau. Now, as a data scientist, we're hopefully going to be able to show you how quickly and easily and visually you're going to be able to present that information back to the business, making sure that it's more widely used, more actionable insight is derived from it, and creating that culture overall.
We would say that in a lot of instances, these two different types of groups actually almost speak different languages when they're looking at the same type of problem. And we're trying to give you a framework whereby you can actually unify the way in which communication and collaboration actually take place surrounding these types of problems.
So let's start trying to see if we can all start talking the same language. Now, through this presentation, we're going to use a business example, and it's going to use terms like correlation and causation. So let's just start talking, for those of you who aren't familiar with those terms, what they actually mean. So the example we're going to be talking about is, let's just assume that I'm a marketing manager and I've just heavily invested in a marketing campaign. Now, obviously, I would like to know whether or not I have a certain return on investment and if I have extra attributable revenue that derived from me investing in that marketing campaign. Basically, I want to see my ROI, and based on that, I can make the decision whether or not we should do that campaign again. Now, let's start talking about correlation, like we see on the screen right here. We see these two lines, they are quite similar. And correlation is not really causation. Correlation just explains that factor X and factor Y follow the same path. It doesn't show whether or not they actually cause each other to behave in the same way. So just looking at the chart here, they seem highly correlated, right? So the question is, would you be willing to make a decision based off of that? Correlation is 99.2%. Seems pretty high. I mean, if that was my eyesight, I would have been a very happy man. Although, of course, I like the fashion statement. So would you be able to make a business correlation is really high? Does that give you enough information to make your business decisions on? No.
Let's actually take a look at what these two real-world data processes actually represent. The divorce rate in Maine and the per capita consumption of margarine. Now, we can always think that there's a chance that these two are related, but of course, it's incredibly unlikely. If I was a divorce lawyer in Maine, I wouldn't be trying to get people to eat more margarine to improve my business. In the same way, I think that it would be pretty crazy for me to actually try to sell more margarine in places with high divorce rates. So this is a pretty textbook example of what we would refer to as spurious correlation. If you just look across enough data sources, you're almost guaranteed to find really high rates of correlation between data processes. So you actually want to have some way of establishing what is actually the causal mechanism for this. Can we try to isolate whether or not something is actually statistically significant when we actually control for more variables in this type of framework? And to then return to the actual framework of the business problem that we were looking at with Irvin before, let's actually look at a dashboard that tries to achieve exactly this. Here we have a dashboard that actually goes in and asks the user to look at our profitability and to choose certain variables. This dashboard is connected to an R package called Causal Impact, made by the Google Data Science team. And the main purpose of it is to actually establish a counterfactual version of what would have happened had we not run that different marketing strategy. Because we know exactly the starting time of the new marketing strategy, as indicated by this line, and we can then see what the actual values of this are, and we can see what the predicted values are. Now, we need the variables in this case to explain the variation in our profitability, but not actually be impacted by the intervention. So the variables that we've used in this case are Google Trends data. We can say that we are a quite small player in the market in this instance. So we can make sure then that we can then say our individual marketing campaign would have no impact on Google Trends data in general. And we also want to have something else that explains the variation in our profitability, our quantity of leads. I can then see exactly what the cumulative effect of this is, over $100,000 difference had we not run the marketing strategy, as well as an indication of whether the impact of this was significant or not. For even the more interested business user, I even have this tooltip that actually summarizes the output of the model, which we can then see here. But now let's go into an actual discussion of, do I actually have all the necessary information to be able to establish these variables as valid using this particular selection?
And that's why this dashboard lives on Tableau Server, because that's the place where I as a business user live. So I can already look at this dashboard and see that indeed we've selected Google Trends data, but the other selection that we have here is my quantity of leads. Now obviously this is a very obvious example, that definitely quantity of leads will be impacted by our marketing strategy and is therefore not a good predictor. But you do need your business users to inform you which factors they are most important to their business. Now this dashboard is published on Tableau Server and is running with R. So I just know that my discount is actually quite a seasonal thing and it doesn't really change that much over time. So when I select discount, Tableau will actually start running the same R script. It will go to R, come back to Tableau and be visualized again. So we now see that we actually have a more valid prediction. It's still a valid one. We still have the green check mark, but actually our ROI just increased. Now, it didn't increase. We just used the right variables for this prediction. Because if we see if our quantity of leads, that also increased because that was actually one of the goals of that marketing campaign. So we want to create this framework for a business user to put in their own information for their analysis to get that business value for them. And that's what you want to do with these dashboards.
So based off of this, we have a particular type of problem here. On the one hand, we're not going to be able to train all of our business users to have an advanced understanding of statistical analysis. This example would have required an understanding of Bayesian time series analysis for a business user to be able to build themselves. But at the same time, a data scientist might not know all of those different nuances of what particular types of data that is available within the business is actually valid in relation to what assumptions are needed for what types of methods. So here we actually have a way to potentially increase the degree of collaboration and understanding as well as visibility between them.
So we have a problem. We want to be able to make more and better decisions based on more informed analysis. So we need to bring these worlds together. Basically, we want to bridge the gap between data scientists and business users using Tableau Server as the platform for them to collaborate. So that is how we propose to solve this. Just integrate R into your existing platforms in which your business users engage to make sure that more insight can be derived there.
And in this way, we are going to now show you actually how many of the components needed for actually performing this type of analysis are ones that you actually already have if you have a Tableau desktop and Tableau server deployment within your organization.
Because visual analytics already went through this process. It went from a report factory to a self-service platform. We made sure that we no longer have this one-way street of people asking questions, report being delivered by implementing Tableau. It's become an iterative process. We've done that with visual analytics, and we would argue that we can do the same thing with advanced visual analytics. The problem is different, but it is familiar, and we've learned lessons by implementing your current Tableau deployment, which we can reuse and adapt to making sure that the adoption of analytical languages within the dashboards is going to be successful and viable long term. And even though a lot of companies still struggle with this, we do see a couple of players already doing this. As we can see from this quote from one of our customers at Hallmark, Tableau empowers the whole organization. It brings advanced analytics into the hands of people who don't necessarily have an analyst's or programmer skill set.
So how do we actually propose going about bridging this gap?
First, we have visual analytics. And visual analytics is all about data exploration and then bringing that to the people in a visual way.
And this can then be contrasted with advanced analytics. So different, more advanced methodologies for us to, for instance, gain insights into what might happen within the future, predictive analytics, giving recommendations for different types of decisions, such as prescriptive analytics. What we're really proposing here is to take many of the lessons learned through visual analytics and combine that to make visually advanced analytics here available through different dashboards within your Tableau Server deployment.
So as Eric already said, what do you actually need to start implementing this? And the good news is that you already have all of those, but that's going to be the next slide. So here at Tableau, we have Tableau Drive. And Tableau Drive is an enterprise deployment methodology for scaling and implementing self-service analytics, using Tableau as a transformational vehicle. And Tableau Drive will allow business users and data scientists to divide their work, but play into each other's strengths. But the solution itself will have to adhere to these 4 key characteristics. The solution in the end needs to be easy to use, fast, powerful, and visual.
And what we really want to stress here is that in order for this process to be successful, having an iterative framework whereby you are constantly promoting dialogue and feedback between these 2 different sets of users with such different needs and skill sets is essential in order for this actually to be implemented and successful.
And this is then what you will eventually need to just start implementing it. And you probably have it already, all of these elements in your organization. You will need Tableau Server for a place to interact between all these business users. And Tableau Server is obviously being fed from dashboards and data sources that are published from Tableau Desktop.
And on top of this, all that you're really adding is this R environment. And within this R environment, you're just setting up a single instance of R serve, which acts as a way to both receive and send back the results of calculations that you have made within Tableau, so that they can then be visualized on a dashboard for your end users. So let's actually go through the different components of how this setup looks like. You'd of course begin with having Tableau Desktop, and you'd want then this to be sitting alongside an R environment that you have access to. Once you're then starting to build these calculations, you would then set up the connection between these 2 and start prototyping what you would actually be building for your end users. But at that point, you of course want to start sharing this using Tableau Server. At that stage, what you'd be looking for is then a way for you to publish this. Happens in exactly the same way as you'd usually publish a dashboard. The only added step is that you would be telling Tableau Server where this R environment is going to be, which we'll be looking at later on during the session. Now, this R environment can be sitting on the same machine, but of course, there's nothing stopping you from having it on a separate machine, which is exactly what we would recommend, particularly in instances where you have a hardware license for your Tableau Server, to make sure that you don't unnecessarily use resources for your R environment that could otherwise be used for your Tableau Server processes.
At that point, you have your dashboards running on Tableau Server, and they're all connected to R. So as an end user, I want to be able to see and interact with those dashboards. And all I do is just the way I've always done. I'll just log into Tableau Server and connect to those dashboards that have an R instance running in them. I can look at those dashboards through all my portals I want to, through my desktop, laptop, tablet, and phone. And indeed, as an end user, I might not even realize that a dashboard is using an advanced analytical platform.
So what is actually then the steps, what are the steps that we need to start taking in order to implement this in this particular way that we are suggesting?
And this is where Tableau Drive comes back into play. So the first step is discovery. And it's basically just assessing a certain business question or a business value. It's also the first step of the report factory, but taking into account the framework that Tableau Drive offers you, it turns it into an iterative process. And it's basically the start of the creation of your center of excellence. And it's a term that we hear quite a bit, but it's key, absolutely essential in making sure that a solution like this is viable and successful over time. The center of excellence will develop and promote best practices, both from a Tableau point of view, but also the statistical validity. It will provide support for the organization and just a place for them to get information and support from. And in the end, it's just the best way to promote that culture of analytics in general, but we argue advanced analytics as well. So if we go back to our example, we want to look at our marketing campaign and whether or not that has increased our revenue. That is my business question. Should I do that marketing campaign again?
But now that I have this business question, I actually want to go ahead and start prototyping this. I want to potentially explore what data I have available, and I can either in my workflow start building this within R, or I can start actually prototyping this right from Tableau Desktop. Now, we'll be working through an example here of how we can prototype one of these types of calculations, but we would want to, of course, highlight the fact that if you want to see this done in greater depth with further highlights on all the different nuances you should be taking into account, Jedi Stats with R, the recording for that session will be available within the next few days, so that if there are any unanswered questions surrounding that, you're very welcome to review that recording and see further details there. But now on to our example. Here I have Tableau Desktop. And I have that first step of knowing where that marketing campaign was beginning, and I know where, what variable I want to start predicting. Now, my first step in this is to establish the connection to this R environment that I have now running alongside this. The first step that I want to take is to make sure that I have successfully connected here. And all that I have to do is to point here exactly to where the external service connection is currently taking place. And at that point, I can then see the place where this R environment is located. Here it's just located on my own machine, and the port that it's listening to. At that point, I can just make sure that I've been able to successfully connect. And I can then also see the results that are being sent backwards and forwards here between my R environment. Now I want to actually bring that R code within Tableau. The process for me doing this is then actually happening through a calculated field. And the different types of calculations that I can actually use for this are these script calculations. Now, the different types of script calculations here just correspond to the different types of results that I will be anticipating to get back from that R environment. Here, I want to start building out the actual counterfactual forecasts from that package that I'm going to be calling from R. So I'm going to be using script real within this instance. So I will just call this my prototype field, call my script, and bring in here all of that code that I need for this particular calculation. Now, in order to make sure that Tableau knows which of the different calculations that this is going to then correspond to, I need to say which of the data that I'm going to bring in that I've loaded into Tableau. You can see here that I've established within my data frame this relationship between arg1, arg2, and arg3. All that this corresponds to is the way in which Tableau will be actually bringing in the order of these variables. So because I want to be using my sum of profit as my first argument, I want to be using my quantity of leads as my second argument, and I want to be using my Google Trends data. I just bring all of those into that field, and the only last part that I want to highlight is that this is already showing me that this is happening as a table calculation. So that, of course, means that I have to keep in mind what it is that I have in my sheet in an entirely different way than with a standard calculated field. Again, I would recommend you to look at that other session for a little bit more of what that actually entails. But here, I'm just bringing in that field, and I can see how all of that data is being sent to Tableau, and I can then see the new prototype calculation that I have brought alongside this. So this is a good way for me to then start visually exploring what it is that I'm actually bringing into Tableau from that R environment and receiving back as a result.
Which is great, because the prototyping phase, better said, has created us with a framework to start answering our question. But now we've got to start moving towards that collaborative platform. So we want to move from Tableau Desktop to Tableau Server. So how do you actually connect Tableau Server to that same R environment? And is that very difficult?
Luckily, Irvin, it's very, very simple. So the entire process actually consists of you just going into our administrative tool, Tab Admin, and issuing these commands. So when my Tableau server is stopped, I will just go in and set the particular address, localhost within this instance, of my R environment. I would then set the actual port that I would be listening to for that R environment. And after those two settings have been made, cleared, all that I have to do is to use tab admin config to save those settings and start my server once again. Very simple process that could be done during a maintenance window for your server, just to get you a sense of what this actual connection would look like when you start testing this.
And the values you put into this frame are the same ones as we actually put into the window that Eric showed earlier. So the two things we're filing in here is just the server location and the port, and you can additionally also fill in a username or a password, but it's essentially the same information. So if you're able to connect Tableau Desktop to R, you can also connect Tableau Server to R. Which then brings us to the next step of Drive, which is building the foundation. We've looked at our business question, we've prototyped that, and we've published it up to Tableau Server. But we have to start looking about our dashboard design. Because obviously in any dashboard we're building, the use of colors and titles and tooltips is extremely important to let people know how to engage with a certain dashboard. That element becomes even more important when we're talking advanced analytics. Not just from a validity of use standpoint, but also making sure that there's no misinterpretations going on as well. And that's where the tools of guided analytics come in again. So making sure that we take our end user by the hand across each and every step here. So it's sort of like on the final dashboard that we showed, we actively engage the end user by saying this is step 1, step 2, step 3, go through all of these and then you get your results. Now interactivity is something that Tableau does as well. I mean, the first interactivity we have is that Tableau Server and Desktop are actually just talking to R. But we also want to present interactivity on the dashboard itself. Now, if we move away from the example for a little bit, and we've looked at Eric now putting in the calculation for the profit with the Google Trends data and a quantity of leads. But we can use parameters in Tableau as well. So we can say, let me just create a parameter, and we have that field over here. So let's say we're doing a standard t-test, or we just want to look at the validity of the p-value of this model. We can just fill in a parameter, call it what should the p-value be, and then we'll just easily list the values that I want to give it to it. So 0.1 or 5% or maybe 1%. And to each data scientist that will just make absolutely perfect sense. Do you want to have 10%, 5% or 1% threshold? But we want to engage our business user. So maybe it would be good if we start incorporating a little bit of natural language to help them know what the dashboard is actually doing. So instead of actually saying what should the p-value be, we can just change that to being how sure do you need to be. And if we're looking at the list of values within Tableau, Tableau is actively asking us to alias the values that we have. Because we maybe not even want to present it as a percentage to our end user. So I can change the name to being how sure do you need to be. And of course, this can be, in the context of this example, can be very valid, but in other ways, it might want to formulate that a little differently, but in case of this example. And then instead of 0.1, I can just say somewhat, very, and extremely. We're still doing a p-value, and we're still looking at the percentages, but we're just portraying them differently to the end user. And Tableau is allowing you to do that just from the creation and the get-go. So let me just create that parameter, and then we can see that being here as well.
Now, beyond parameterization, there are a whole number of different ways that we can actually use the lessons learned when we've been deploying visual analytics within our organization to actually different types of calculations that you'd be bringing back from an R environment. In many ways, when we are thinking back to the example of this p-value, displaying a whole long sequence of values to our end user might be entirely without meaning. But we can actually very visually convey what it is that we want a business user to act on, just using very simple little lessons that we were actually using within our dashboards already from the get-go. So within the example of this, where we're looking at potentially having a certain check mark, if I go back to our Tableau desktop, I can see here that the check mark that I have on this dashboard is nothing more than a calculation that's based upon me extracting here the p-value for the entire summary statistics for the model to see if we actually had a statistically significant intervention. And after that point, me going in and just having a calculation that looks at whether or not at the 5% level we have a statistically significant result. Now, looking at what Irvin was doing before, I can actually just change this from being a static value, as we were looking at here, to just say that I want to actually use this as the basis of my new calculation, where it'll just compare that parameter. So I now have a way to be able to dynamically select what the decision rule should be for my business user without ever having had to teach them around what decision rules are or what p-values are, but still to give them some sort of inclination or intuition surrounding what is the interpretation of these forms of results that we're bringing in and out. And that, of course, is what is crucial when you're actually looking at having this dashboard be understood by more business users than the ones that were just involved in the designing of it. And in that situation, it's crucial to have all of these design elements embedded within it.
Yeah, because if you have all the design elements in it and you've built it for consumption, you're then ready to start scaling out the solution. Now, we would argue that then in this situation, there's two types of scaling. First one is just the fact that we're going to have more users actively engaging in building these dashboards and these solutions. So the iterative process across the organization is just going to include more and more people, powered by that center of excellence. Now, the second point is just the availability of advanced analytical dashboards will actually just up the number of people actually consuming the dashboard, upping the number of people that are just going to be interacting with this.
But beyond this, when we actually look at the number of people consuming a dashboard at the same time with higher concurrency rates, we'd of course want to make sure that we had sufficient resources to actually support that. So, from the point of view here of the R environment that we were running, that is of course a single one that was handling a single request. But when we're looking at doing this at scale across an entire organization, we could of course have several different R environments be made available to actually handle the requests coming from these dashboards in a way that actually balances the load between them equally. So a very, very common way that we see that this is actually handled is, for instance, through HA proxy. That then acts as an intermediary to take those calls from Tableau Server to any of the R environments that can then handle these requests concurrently if you have several dashboards being used at the same time, which is, of course, the end goal of this entire process of how you're designing this. But beyond that, there are certain performance considerations that we have to take into account as well. When we're looking at bringing in, for instance, different packages into each of these R environments, or the results of a machine learning exercise, doing that already from the get-go when in the R environment without actually having to call that within each and every R script is a great way to ensure that you get the most performance as opposed to manually calling that each time that a calculation is sent. So on that basis, you have certain elements of how you can actually start designing this from the very beginning to handle many requests from the many users at the same time.
So let's summarize what this solution actually entails. By scripting R directly into Tableau, you're going to be able to perform more sophisticated statistical analysis. You're going to empower your end users to set their own parameters, and the resulting scripts will run into R, but you've built a framework that is secure and the governance is running all through server anyway. And you're going to have a way to more easily and immediately communicate those results in a more visual manner. You have all the elements in place. You got Tableau Desktop, you got Tableau Server, and you got R. Use the lessons learned from implementing Tableau Server and Tableau Desktop to start upgrading your solution by implementing these advanced analytical elements. Whenever we're designing a dashboard, the 4 key characteristics as part of Tableau Drive always come into play. So always be on the lookout that your solution is easy to use, fast, powerful, and most importantly, visual. And use those steps as Tableau Drive all the way from discovery, prototyping, building that foundation to finally scaling it out across the entire organization. And we'll have resources within the slide deck as well. It comes with a full framework, checklists, every step along the way to guide you in that journey.
Now, some of you might have been sitting here if you also came from a stats background like myself and maybe started thinking, when we were writing that parameter, for example, is how sure you are really what a p-value is going to mean in this context. Shouldn't you include a nuance there surrounding what was actually the intended treatment effect? What was the sample size? There are plenty of different types of nuances that we could have brought into this, but the crucial component is actually around having your business users be able to engage with tests that actually give them a higher degree of assuredness that they're making valid decisions, and actually just have that conversation be started. Because right now, we see that there are certain sets of users within organizations that are never preoccupied with this and never get access to these more advanced forms of analysis that they're able to control in any meaningful way, like we were able to by choosing the variables involved. What we really see as crucial in this process is to actually just get your champions involved, both from your data science teams and your statisticians and your business users. Find those people who are passionate about answering these types of questions and actually just promote this environment where they can speak openly to each other and show the results to a wider audience. We think that at that point you shouldn't really let perfect be the enemy of the good here. Just start that iterative process and see where it takes you. There might be lots of different use cases that you never would have dreamed of had you just been sitting with one set of users and not both of them in the same room at the same time.
And with that, it's actually as simple as we want to propose it out here. Just get out there, get started, and be successful. Getting started is actually the crucial element here. We don't propose that from the first step you'll get these things right. But when you get started, get iterative, get talking amongst each other, that's where that culture starts to happen. So, this is the very last breakout session of this Tableau's conference. Big awe, everyone. So we don't have any related sessions to advise you to, but we do recommend the Jedi Stats with R if you want to look at the information on how to script in R. Achieving Goals via Analytics by Bora Baran is a great session to give you some use cases using R and Python for you to get inspiration on which questions you could potentially start asking. And if you're more interested in Python, there's a Tableau plus Python session that shows you how to script that. Now, we didn't want to send you out empty-handed with no next session to be able to go to, so we thought we'll just list some of the best happy hours in town. So We personally endorse every one of these, so perhaps we will find each other there later tonight. And then as a final remark, please fill out the survey. We read, and I know everyone says this, but we do genuinely read every single remark. So please let us know what you want to see added, or if you thought something was good or could be better, please let us know. And with that, thank you so much for being here. We do have time for some questions, but thank you so much. And I'm actually going to do a little something, and he's going to hate this, but I want an extra applause for Eric. He was ill all week, and he skipped day to night out just for you guys to be here. Thank you. Thank you so much. There should be microphones in the room, so if there's any questions, we'll linger around as well if you want to ask them personally. Yeah, I see one over here.
So the question for everybody who didn't hear was, why did we have the session be specifically targeted towards R and not towards Python, given that they're actually entirely interchangeable in this. They're just an external service that you'd be calling. And you're actually entirely right in this observation, because any of the lessons that we were showing here from the context of R could just have been actually ones that we were calling from Python. So it was partly a planning exercise that led to this. We'd say, though, all of the things that we've been talking about equally applicable to Python.
It's also a personal preference in some cases. Some people just like R better than Python and vice versa. The session itself is mostly about that culture of analytics and how to get that settled. And we, in this session, just chose to use R as that platform.
So the question from the audience was, do you have to start rserve every time that you open up a workbook? You need to have an rserve instance running every single time that you are going to be sending something from a workbook to that environment, be that from desktop or from server. So our recommendation would be just have an rserve instance running at all times that can then receive those calls. Exactly. And that's also related to the fact that it's a table calculation. So it has to be created on the fly as the workbook is opened and is not actually stored in the data source. Any further questions?
I see one over back there. There's microphones as well. So if anyone wants to go to those, so then we can hear them.
Then we'll get to you, sir, after that.
This is a follow-up to the first question. Can you make a similar connection with SAS?
You cannot make a similar connection with SAS. There is, of course, if you have some way of integrating actually something through Python to SAS. I don't know if that's something that is readily available, but I wouldn't say that this is available through SAS and in any supported way by us, as a short answer.
Okay, thanks.
Do you know, especially with rserve, if there's evidence that invoking the script and having those parameters passed through Tableau invokes a really appreciable performance overhead as opposed to running the same script directly on rserve, or is it pretty negligible?
I would say that it would be pretty negligible, but I think that it's difficult to speak in a generalized way around this, because the way in which Tableau sends different things to that R environment, it can be heavily context dependent. If you have a particular use case in mind, I'm happy to speak to you after the session.
Cool.
Hey guys, great job. So I've got one of those like 5-part questions, but I'll distill it to like 2.
Okay.
So I'd love to be able to do this at our organization, but there's a lot of networking questions, there's security concerns, resource constraints, etc. So one part of my question would be is like, how do you go about building consensus that this is something that we should take, network engineers and dev time to implement? And then also, what kind of resources exist out there that document how RServe and Tableau connect that I could hand to my network people to get them kickstarted.
Got it. All right, so the resources are going to be on the slide deck anyway. So there's a couple of white papers right over here using R and Tableau that just talk specifically about how this connection is being set up. Also defining analytics and just advanced analytics in general in cooperation with Tableau. So just find the slide deck after the session and you'll just be able to read those white papers to pass that on. To answer your first question, that's the cup of water. And then the second question is around security, I feel, right? So how do you make sure that you that the organization is fine with this solution as well?
More just like that the organization sees the value in going about implementing this.
I would say that the main thing is find a use case. Find a use case where having business users actually be able to control what is going into a model instead of having to send an email to the data science team, wait a long time in a queue. What we're in essence, I think that is really the key component of actually building enough political capital in an organization to get this over the threshold. Show people that this is going to save them time and it's going to save data science teams hours doing more or higher value activities than just doing ad hoc analysis. I think if you can show that in some concrete way, that's really the way that you can solidify a case for this to be deployed.
Yeah.
Wonderful, thank you very much.
No problem.
And with those resources, you can also see on the websites and on our community, if you search for Tableau and RServe, we have a bunch of resources written by the guy who built this, Bora Baran, around this, and I'd recommend reading around there on the community around different ways in which people have overcome some of the more common challenges. Yeah. You, sir.
I have a question for the data scientist. I'm just a software engineer. You didn't mention anything about machine learning, the model. Is that a totally different topic? Since your R script going to call the model, since there's a maintenance, enhancement, changes, the whole part about maintaining the model and productionize it.
So just so I understand your question correctly, how do you actually maintain a model that you would then be calling from one of these scripts within Tableau in a proper way?
Correct.
So I would say that the best way there is just to separate these two processes. Training the model in one environment and then actually just making that accessible to the environments that will then be called on to make these different commands through Tableau. I think that separating these two is definitely the way to go because of the way that Tableau does all these things on the fly. Training the model first and then just using that to actually call the results within Tableau is definitely what our recommendation would be. But if you have any concrete examples, we can again speak around this after the session. We'll be lingering here.
Okay. Got over
Thank
there.
you.
I've got a use case in education, so I'm working a lot with students in an international school, and I've got a lot of applications for R on the classification side, i.e. what kind of problems do people have and what kind of opportunities do we have, and then I've got some treatment and intervention program evaluation sort of applications as well, so what interventions work, what things are significant in helping people realize their potential. But in the security area, I've got lots of problems with my IT department not wanting to let people in. I've got Tableau Server online, not in-house. So if I have the online setup, how do I use when you drew your triangle showing that you need an R server, how do I move the R prototyping server that I have on my development environment up to Tableau Online?
So important nuance here, and it was mentioned very briefly on one of the slides, but it wasn't actually one thing that we concretely mentioned, but it's very important, that this is currently not available with Tableau Online. It's only available with Tableau Server. But if I understand you correctly, were you saying that you had Tableau Server running in a virtual machine in a public cloud?
No, it's only on your service, Tableau Online.
So in that case, unfortunately, it isn't available for you to actually be using it right now. I can't speak to what the future might hold, but at the moment, I'm afraid that it's not available.
Okay, that's bad news. Thanks.
Sorry.
I believe you were, yeah, sorry.
Yeah, okay. I have two questions, but before that, I want to answer to the fellow about the rserve instance. One way you can do that is to put that command on the task scheduler if you're running Windows and schedule it to run like once a day, so you know that you have the instance running without having to do the manual work. That works for me. I have two questions for you. One is technical, the other one is more of the organizational. The technical is, in most of the instances, the Tableau Server administrator is in a different organization, department than yours. You can only control what port that is, my reports are being rendered in, so deployed in. So how do you do that? Can I force, if I find out what the port is, can I change the port on my end on the desktop so when I deploy it, it's the same thing? That's the technical question. The organizational question is, and you kind of alluded it in the beginning, causational versus
Correlation?
correlation, thank you. The truth of the matter is that you have theoretical statistics and business statistics, which basically is what you alluded to. And people from both sides of the aisle need to understand that. It's nice to theorize and say it can be two different entities and one trusts the other. But an analyst should know statistics, and then it's more the causational part. It's also the significance part. R square of 0.3, 30% in business statistics is pretty significant. It's completely insignificant on theoretical, okay? 30% chance of preventing fraud in a billion-dollar industry is still millions of dollars. So that's important to know. In the same way, the data scientist needs to understand how the business is run so they can ask intelligent questions. So I need your take on that. If a good team, the champions, should overlap in terms of disciplines versus being completely distinct.
Absolutely. That is why we talk about the center of excellence. So that's sort of the nucleus of your business. So that's where those worlds collide. You have your data scientists in there, your business users, and then potentially someone who can build those dashboards. But it's in there that the overlap areas are going to be translated to something that the end user can then consume later on. So if we, for instance, define that 30% is still valid for that use case, we could build the framework as such. Because everyone will be focused on a little bit different. As a data scientist, you'll be validating the model and building the calculations, making sure that everything is set. As a business user, I just engage with it, and I'm just curious to the number that I'm going to look, because that's what I'm going to pick up and then bring back to my business to define whether or not, in our example, I want to do that marketing campaign again. But the center of excellence is where those worlds collide, and it's also absolutely key in making sure that those two camps continue talking to each other. If you don't have, and it also should have like an email alias and potentially an office hours in which they can just answer questions and the business can come to them. But it sort of evolves around there and keeps it turning around, keeps it spinning. That's on the business side. And then the technical question.
So if I understand your technical question correctly, you can customize the port that Tableau Server and Tableau Desktop listen to. And you can also change which port that rserve is going to be using. So provided that you know then what your IT department wants to be doing from a security perspective on what port, you can just configure that in both instances to make sure that it's all synchronized. You saw that there within Tableau Desktop, managing the external service connection, you could just customize that port, and you could then do the same thing for Tableau Server. To your question surrounding correlation, causation, should we have more business users become more statistically savvy? I mean, you're sort of preaching to the choir here, maybe from my side, right? I think that it's absolutely essential. I was sort of shocked coming out of grad school and realizing how many people work with data and aren't familiar with significance tests, understanding more basic things surrounding when we can actually say things are statistically different from each other, that's not even a phrase in certain organizations that has any meaning. I think it's ultimately, though, a philosophical question around how much engagement you want from business users and are ready to actually accept time investment-wise? That's a bit of a fuzzy answer, but I don't think that there's a defined right one at this point. But I believe we had one further question here.
Yeah, I have 3 questions actually.
Okay,
So
3
the
questions.
First one is,
We'll see what we can do in the time.
in Tableau Desktop, if I'm doing that external connection, and it can be to my local machine or on our server, right? So if the same dashboard I publish on Tableau Server, then I don't need that external connection if I have a server talking to our server. Is that something like that?
So if you have, so if I understand the question correctly here, you're thinking about having an R instance running on your own local desktop, and in another case, one that is running on a virtual machine someplace else.
Yeah.
And if the syntax would be the same. Because the syntax would be entirely the same within each instance, provided that they're both come with the same installed packages. The only difference would be the address at which you would be pointing this at. That's the only difference that you would have between these two.
So a dashboard or a workbook in Tableau Server, it need to have that external connection set up, or it doesn't require if my Tableau Server is connected to our server?
So in order for any calculations that use R scripts to actually be properly rendered on Tableau Server, you need to have that connection set up from tab admin. Otherwise, it'll just say, I don't know what to do with these scripts. Do you want to reset this view? So you have to have access to tab admin for that in order to be able to, for it to be able to run on Tableau Server.
Or access to someone who has access to it.
Yeah.
It's just those 2 lines.
Okay. So second question is, our Tableau server is on AWS. So for the performance-wise, like our server also should be on AWS, or it doesn't matter like location-wise, or is it okay?
I think for network latency points of view, having it within the same AWS data center makes sense. Having it, I think that's, I wouldn't say anything too much beyond that though. Having it running with, if you're on an interactor license and you're just able to have a beefier virtual machine on EC2, then of course having R running on the same machine could be an easy way how to set this up in the beginning. If you're going to be handling a lot of calls to your R environment, then having an entirely separate virtual machine and the connection in that way would be our recommendation.
All right, and like one connection can have multiple instances of our server, like our environment?
Yeah, so that was what we were discussing with HA proxy, that HA proxy can act as an intermediary, as a load balancer between several different R environments at the same time. So provided that you just define within HA proxy where each of your R environments are located, you can then have the calls come from Tableau Server and then be equally balanced between each of those instances.
Okay. And last thing, just a second.
We'll also be lingering here,
Yeah,
as
we'll
we
be
mentioned
lingering
before,
on.
if you want to ask a question then.
Sure. All right.
Well, in that case, thanks for all the lingerers here.
Thank you so much.